The directions state to multiply. For example A, we have the binomial 3x plus 2 multiplying another binomial of x plus 5. Well, how do we do this? Good news, you already know how. It is the distributive property. In this case, looking at the first binomial made up of 3x plus 2, these are the values we must distribute to the second binomial. So the first term was 3x. So we're going to look at it as 3x times x plus 5, and then we distribute the second term of positive 2 times the binomial x plus 5. Now if you look at that, it looks like distributive property again, and that is what we do. We now have 3x times the binomial x plus 5 plus 2 times the binomial of x plus 5. We now need to distribute the 3x and the 2. Starting at the beginning, 3x times x, 3x times 5. We're done distributing the 3x. Now we distribute the 2. 2 times x and 2 times 5. Now, when we have a binomial times a binomial, that means 2 terms times 2 terms. Well, 2 times 2 is 4. And if you notice, we currently have 4 terms. That's a good thing. Now let's carefully simplify those 4 terms. The first term is made up of 3x times x, which simplifies to 3x squared. The next term is 3x times 5, which simplifies to 15x. Next we have 2 times x, which is 2x, and 2 times 5 is 10. It may look a little more clear to see those 4 terms now. From here, we do want to, if possible, combine any like terms. Do we have any like terms? We do. I hope you notice that the middle terms of 15x and 2x can be combined. And so our answer will be 3x squared plus 17x plus 10. Now, that was us approaching this problem using the distributive property. We are going to approach it the visual way using the boxes. So how do we do that? Well, we have the binomial of 3x plus 2. Because it's a binomial, we are now looking at 2 rows. 3x will be the first row or the top row, with a positive 2 being the second row. Now it's multiplying a binomial of x plus 5. So across the top, above the top row, we write x plus 5. And since it is a binomial, it means we will have 2 columns. All right, now we need to find the area of these 4 separate regions. Starting in the upper left, the dimensions are 3x by x. Well, 3x times x gives us 3x squared. Now, working in the upper right section where we have the dimensions of 3x by 5, we multiply that area, and 3x times 5 gives us 15x. So we have simplified or found the area of the first row. Now we look at the second row. The second row has the dimensions of 2 along the left and then x and 5 across the top. Starting in the lower left region, its dimensions are 2 by x. Well, 2 times x is 2x. So we write positive 2x. The lower right region of our box method has the dimensions of 2 by 5. Well, 2 times 5 gives us 10. And what you'll notice is these numbers look familiar. Each of these areas was our 4 terms, but also we need to combine any like terms. Notice 3x squared is the only x squared term, but we do have 2x and 15x in 2 of the squares. They are like terms and can be combined to form a positive 17x. And then the last remaining square is the constant plus 10. And so notice, it's the exact same values we arrived at when we distributed. which goes to show you can choose either of these two methods. You may distribute, or you may use the box method. I will be using both methods throughout the examples. For example B, we have a binomial of x plus 4 multiplying a trinomial of 2x squared minus x plus 3. In this case, I am going to choose to use the distributive property. The binomial being distributed consists of an x and a positive 4. So let's carefully distribute. It'll be the first term of x times 2x squared minus x plus 3. And then it's going to be plus 4 times the trinomial 2x squared minus x plus 3. Now we can distribute again. X times 2x squared, x times negative x times 3, 4 times 2x squared, 4 times negative x, and 4 times 3. Now that we have it all distributed, let's simplify each of these terms. And if you notice, a binomial times a trinomial means 2 times 3, which is why we currently have 6 terms. The first term, x times 2x squared, results in 2x cubed. The next term, x times negative x, gives us negative x squared. The following term, x times 3, can be written as positive 3x. 4 times 2x squared simplifies to 8x squared. Then we have 4 times negative x, which gives us negative 4x. And finally, 4 times 3 gives us positive 12. So here we have our 6 terms, but we're not done yet. If possible, we need to combine any like terms. Well, when we write our answer, we want the highest power written first, and the highest power is the x cubed. But it is the only term, so 2x cubed will remain in our answer. Now we look for x squareds. Notice we have a negative x squared and a positive x squared, which can combine to give us a positive 7x squared. Now we move to our x terms, and notice we have 3x minus 4x, which simplifies to negative 1x or negative x. And then finally we have our constant, which is plus 12. So our final answer is 2x cubed plus 7x squared minus x plus 12. Example C, we have the quantity 6n minus 7, quantity squared. Now this should look kind of familiar. We know about exponents. We see a power of 2, but we need to recognize the base. What is the power linked with? Well, in this case, the base is 6n minus 7. So in other words, this really means 6n minus 7 times 6n minus 7. And I strongly suggest you do write it out twice. Now for this example, I'm actually going to use the box method. So on the side of my paper, because 6n minus 7 is a binomial, I am going to draw a rectangle that includes 2 rows. And then because it's timesing another binomial, I'm going to have 2 columns. And so on the left-hand side, I have 6n for the first row and minus 7 for the second row. For the first column, I have it 6n, and for the second column, minus 7. Now, like before, I'm going to find the area of each of these regions, starting in the top row, left to right. The first one has the dimensions of 6n by 6n. Well, 6n times 6n gives us an area of 36n squared. Continuing on the first row, we now have the dimensions of 6n by negative 7. Now be careful with your signs. 6n times negative 7 is a result of negative 42n. We've completed the top row. Now we turn our attention to the second row. On the left, it has that negative 7. Now, the first column is made up of 6n, so the area of negative 7 times 6n gives us negative 42n. Continuing the second row, the lower right section, we have the dimensions of negative 7 by negative 7. Now negative 7 times negative 7 gives us a result of a positive 49. Now for here, we want to simplify and combine any like terms if possible. What you'll notice is we only have one term that involves an n squared, so we keep the 36n squared. But we do have two squares that only involve an n. We have a negative 42n and another negative 42n. Since they have like terms and like signs, we add keeping the sign, making it negative 84n. And then our final lower right square is our constant, which is a positive 49. And so our answer is 36n squared minus 84n plus 49. Example D, we have the binomial of m plus 2/3 times the binomial m minus 1/3. Now, I know you like this problem. You know why? Because it has fractions. I'm kidding. I know most students do not like this problem. However, you do have the skills to complete it. In this case, we are going to distribute. The first term we have is m, and it's going to distribute the second binomial. So we write it as m times m minus 1/3, and then we distribute the positive 2/3, so plus 2/3 times m minus 1/3. From here, we distribute again. M times m times negative 1/3, don't forget that sign. Now we distribute the 2/3. 2/3 times m, 2/3 times negative 1/3. Now we simplify each of these terms. M times m results in m squared. M times negative 1/3 is negative 1/3 m. 2/3 times m is 2/3 m. And then 2/3 times negative 1/3. Be careful here. Positive times a negative is a negative. And we multiply fractions by doing top times top, bottom times bottom, which gives us a negative 2/9. Now, do we have any like terms? Yes. Notice the terms in the middle, negative 1/3 m plus 2/3 m. Now, the case that these happen to be fractions, we have to remember our addition fraction rules. To add or subtract fractions, we must have a common denominator. Do we? Good news, we do. So we can go ahead and combine these like terms. The m squared is the only m squared we have, but negative 1/3 m plus 2/3 m can combine to give us a positive 1/3 m, and then we keep the constant of minus 2/9. So our final answer is m squared plus 1/3 m minus 2/9.